Good afternoon. I'm Cheryl Kemp, Content Director at the WER, and I'd like to welcome you to today's webinar. Today's session is called Building a Big Data Service and is presented by Joseph George. He's the Director of Server Big Data Strategy and Density Optimized Servers at HP. Before I hand it over to Joseph, I want to let you know that there will be some time for questions at the end of the presentation, but you can ask them throughout the session using the question function in the webinar software. You should see a box on the left side of your screen where you can ask questions. If for some reason you can't see that box, there's a red Q&A button at the bottom of your screen that will make it appear when you click on it. If you ask a question and it doesn't get answered because we've run out of time or if it's a bit too specific, someone will reach out to you by email after the webinar. Finally, there will be a video archive of the webinar available if you want to watch the presentation again or share it with someone else. It will be in the archives at thewer.com/webinars by the end of the week, so make sure to check that out. You should get an email with the link to the presentation as well. Okay, let's get started. Welcome, Joseph, and thanks everyone for joining us today.
Thank you very much. It's a pleasure to be here today, and before I kick this off, Cheryl, are you able to see the slides in the view?
Yes, I can. If anyone else has a problem, you can just type that into the question box as we mentioned at the beginning of the webinar, but I can see it fine, Joseph. Thanks.
Okay, great. Thank you. All right, great. Once again, as Cheryl indicated, my name is Joseph George. I'm the Director of Object Storage Solutions and Big Data Solutions at HP, as well as Density Optimized Servers. And just as a little bit of intro about myself, my background includes a variety of things that I've done in my career, but most recently a lot around big data and a lot around object storage, especially in the open source space, as well as projects like OpenStack, and having served on the board of directors there and launched businesses at a number of companies around cloud and big data solutions. Very happy to be here today, and look forward to spending the time with you in the next few minutes to talk a little bit about considerations for launching big data service in the hosting world. So as we are thinking about what we'll talk about today, let me just talk through an agenda here. First of all, I did want to talk a little bit about the opportunity that's out there. What in the businesses that we have to take a look at what the business cases are for new services that we make available to your customers, and understand what type of forecast we're looking at, what type of total addressable market. So we'll spend a few minutes talking about what a number of analysts and what number of experts see as the big data market, and really the opportunity that's available for the hosting market to be able to get in and offer those types of services. And then once we've actually gotten into the considerations, we'll talk about a number of things, a number of factors to consider when we look at a big data service and implementing things, such as the types of data that are out there, where they're generated from, and how they're consumed. Looking at scale up or scale out architectures around how you actually implement these big data services. What are the technologies out there? What do they require from a scale up or a scale out perspective? And speaking of those technologies, we'll talk about open source options that exist out there as well as commercial options, and talk through the benefits and considerations you need to think about when you look at either of those technology types, and what makes sense for you as a service to pull together. And speaking of services, that 100% of what we do is not run completely by our customers in the web hosting business. There are services from software vendors, from vendors like HP, in terms of consulting, in terms of support. There are a number of aspects where you have to consider what level of services are required in the implementation that you roll out. And then we'll go a little bit deeper into the infrastructure and some requirements there. And we'll talk a little bit about what HP is doing in this space and how we can work together to partner for success. So let's talk about that business opportunity. This is a slide that I pulled as a part of some of the analyst research that we took a look at, specifically IDC. The growth projected for that we're currently in, just for this few between now and the next 2 years from now, has come up to almost 32%. And some folks would even argue that that's probably a little bit on the low end. It is a $16 billion market just in 2014, and it is one of the few spaces that's growing significantly faster than the overall IT market. And I think we've seen data points as much as 6 times faster than the overall IT market. And when we look at this market, it includes a number of things like servers, like storage technology, like services, like software. There's a number of things that are available in terms of what this opportunity looks like. But there's a way for looking at this other than just the ability to store a bunch of data. Really, what you're trying to provide to your customers are value, and so it's not just storage. It's not just keeping data preserved. It's storing the data. It's analyzing data. It's being able to retrieve data as needed for your customers, and the ability to be able to process and organize and analyze large amounts of data. That's where the need is among the customers right now. If you think of, and we'll go into some of this later, think about just a few brief things that you may have done just today that generates data. Checking your social media status, using your cell phone in any way, using GPS in any way, obviously email, obviously any of the tools you have in your environment today that are logging web traffic. Those are all things that you and your customers are looking at in terms of being able to analyze data. And so there is now a need in the market, technologies that allow your end customers to make sense of this data. As an end user, your customers may want to understand what matters to their customers. What are some of the things that are trending? The things that may impact their bottom line. To be able to analyze and process that data quickly is really what the need is there. And there's an opportunity for the web hosting vertical, that whole to take a piece of this $100 billion global market, and that's really what we want to spend our time talking about here today. So let's get into some of the details that I talked about, the considerations, and let's start with data types. You may have heard the terms structured data and unstructured data, and let's just spend a few minutes talking about what that is and what we're seeing from the market. Structured data has typically been referred to as what you would see in relational databases, databases that are formatted very, very cleanly. And back when databases were really in their heyday, and obviously there still is a lot of structured data that needs managed today. But early on, a lot of the data that was generated, and as you can see here, even as recently as 2010, a majority, 90% of all the data that was out there was unstructured data. It wasn't just of the structured variety. So even as recently as 2010, structured data was a big portion of it. But you can see the actual sizes of the data, the amount of data was significantly less than we're seeing today. And if we flash forward ahead to 2015, and again, think of all those things that I mentioned, all the areas where data is being collected and being generated by users, by you yourself as an individual, by your customers. The forecasts are, that unstructured data will actually grow significantly. And think of all the social media updates you and your kids and your friends are all putting up there. There are staggering data points around such unstructured data that is. So let's talk about what that unstructured data is. Data that doesn't fit the model of structured data in terms of a clean, clear, relational database. That's really the type of thing that we talk about when we talk about unstructured data. So what types of data is that? Includes audio, includes video, it includes graphics files, anything that doesn't fit neatly into a relational structured column and row database are now data points that can be leveraged by your customers and can now be leveraged and processed and analyzed by the new technologies that are emerging in the spaces of object storage and big data. Multimedia is a very frequently included part of this unstructured data, but there are other things like email messages, like word processing documents, presentations, web pages, all sorts of things that not as maybe not as graphically robust as video or as just graphic files, but still are things that are considered unstructured because it doesn't fit neatly into the space. So when you're thinking about starting a big data service, you got to figure out, does your focus, your customer set, are there services that are needed for in your area, in your market, for unstructured data, or for structured data, or for both? And the reason that we mention that is that the requirements from a hardware, software, and services perspective can actually differ depending on the type of data that you manage. And we'll talk a little bit more about that later on as we get into it. Now, speaking of different data types, let's just do a quick primer on some of the terms that we'll talk about as we go into the webinar here. And specifically, I want to talk about block storage, file storage, and object storage. And let's actually talk about file, because that's something that the file is kind of the middle block here. Let's talk about that, because file storage is something that most of the customers I interact with, they kind of get that file storage has been around for some time, and we get that whole notion. It's a file stored in a structured in a file system, where it's basically a hierarchical way of organizing files, so that if there's a file that you need to know, it can be done fairly quickly by describing the path to that file. That's really the main attribute around file storage. There are certain attributes about it that we can describe that file with, such as who owns it, last one that accessed it, what its size is. That's all attributes that can be stored as metadata when it comes to a file system, and that's something that I would guess that most of you are familiar with. And it is a means of storing data that's been around for some time. If we shift down to that block row there, the best way to think of a block is basically a chunk of data where when you get multiple blocks together and you combine them in the appropriate way, you can create a file. So blocks are pieces of files that, when created, it will actually look like as in file storage. It has an address, and the applications that are reaching out for that information, the block, retrieves that block by making a SCSI call to that address. It's a very microscopic way of actually controlling storage. It actually allows the application to decide where these blocks of data need to reside, where they need to be placed, and how to organize them, and how it's actually combined or taken advantage of, how these blocks are used, is really left up to the application. There's not really any storage or metadata associated with the block other than the address, and even that address is really about the data itself, not just about the block. So really, the block is a portion of an overall. No real associations, no real owners. It takes on meaning when the application that's controlling it combines it with other blocks, and that's when it has meaning, and that's when it has relevance. So that kind of leads us to objects, how a lot of the more advanced storage systems today are handling it, and this spans all the way from server-based storage to traditional SAN-based storage as well. You can actually do quite a bit of, look at a variety of technologies that handle object storage. But let's talk about object storage for a second. If you view object storage similarly to how object-oriented programming is done, you know that there are variables that are created that have attributes that can be inherited. It's a similar thing. It's not a one-to-one, but it's a similar thing where the data, along with all the metadata that's associated to describe it, its address, its owners, its association. It's all bundled up and given an ID, and so you can actually access the object, which includes the file and all of its data. And that way, when an object is reached out to get retrieved by an application, it actually presents an object ID, and then it actually sees all that information in that amount. Now, the unique thing here is that files and file systems tend to be a little bit more deeper, if I can say it that way. The objects in an object store is actually more or flatter than you would see in a lot of file systems here, and that's because it's in a flat address space, and that's important because it allows your applications to access these pieces of data very quickly rather than going through a hierarchical search pattern for file. Object allows you to get to as much of the attributes of the data as possible very, very quickly. So it allows, object storage really allows you and your users to take advantage of quick access to data, gives them flexibility, gives them as much information about that data and its ownership and who's accessing it and where it resides. Object storage actually gives a fuller picture to you and your customers on specific data points. And you can kind of start seeing how that the object storage component starts opening up a number of opportunities for analytics that was not available in the past. Objects just nature allow you to be able to access and analyze and to be able to cross-reference data with a variety of variables and attributes, and that's really kind of what's interesting about objects today. So let's move on and let's go from the types of data to scale. And as I mentioned earlier, the point here is really around scale technologies and scale out technologies. And the question is, which one is better? And the answer, as with most things, is it depends. A number of relational databases of the relational database and scale up variety. And there's a lot of benefit to actually going that route depending on the databases the data points that you're accessing. If it is relational data, it's actually a perfectly fine way to take advantage of that data. But as we said, as we get to more and more evolved data types, and as structured and as unstructured data starts becoming far more pervasive, let's also admit that with the advent of IPv6 and with more and more devices that are wearable, and with more and more of our, even appliances having their own IP addresses and networking capabilities, appliances, I mean even kitchen appliances having their own IP addresses, you can see how the amount of unstructured data that will be available to be consumed and analyzed is going to grow significantly, where more of the scale-out architectures are really more advantageous for unstructured data. Scale up in this model actually represents very relational database oriented starting point, and then building management on top of it and providing you more insights and building more sophistication up the stack. There's a lot of benefits that come with that: ease of use, ease of analysis, and there's a lot of great vendors that are out there, including HP, that do quite a bit in the scale-up space with a number of satisfied customers. The other end of it is there are also, as we look into big data and object storage, we start looking at scaling out. And what scaling out means is taking pieces of your components of your infrastructure. So let's say a compute node, some local disk drive, and then some level of software that's on it, and then rather than building up the stack and adding more software and more services, you actually just replicate that one component over and over again. That would be what scale out actually is. So if you had a compute node with some local storage, and let's just say in this case some commercial software run your object storage, in terms of scale out, you would not build on top of that up the software stack. you would just replicate that over and over again. And the technologies that exist out there take advantage of the ability to scale out, making their search algorithms and their analysis algorithms take advantage of that scale out architecture. So when it comes to scale up, a lot of customers that value kind of ease of use are really going a little bit more toward the scale up type of model. Is a great use for a lot of our enterprise customers that have a lot of traditional storage already in their environments. But for our more scale out customers, which include web hosters, we actually see the scale out model where you're able to replicate these server-based environments and these individual server nodes. You'll tend to find them more pervasive and actually more cost-effective because you're able to replicate one thing over and over again. And rather than add more software up at the top layer to actually accommodate more scale, you actually can add more nodes, and the I/O, the performance stays consistent as you actually scale out. So it's actually a really interesting distributed approach. And over time, and again, this is relevant to our web hosting community, the more you scale, it ends up being more cost-effective over time. So it's actually a really interesting model that the more you distribute it, the actual costs actually get better. The other side of that is that with the scale-out model, it actually can get fairly large and fairly complex unless you're using specific server designs that are built specifically for those models, and that actually falls very nicely into some of the areas that I work in with density optimized servers. So let's talk a little bit about the different environments and some of the things to consider when you're looking at scale up versus scale out. So let's talk about scale and the throughput. Obviously, throughput is going to be important, especially when you're going to be delivering this as a service to end customers that are outside your data center or your colo. It's going to be really important that the number of proxy nodes or the number of gateway nodes gives enough scale to the clients that are reaching on the other end. You could actually see some of the performance issues, network issues that plague a lot of customers, a lot of hosters. Can actually obviously limit your overall throughput as well. And the parallelism of these storage volumes, it contributes to the throughput. So even as you're going through the higher levels of network output, 10 gig, 40 gig, 100 gig at some point, the parallelism of that is actually going to contribute to the throughput that your end users are going to see. When we think about capacity, the number of storage nodes are going to provide scale as well. So we'll talk a little bit about some of the architectures that we put in place. But if you're able to maximize, for the scale-out model, if you're able to maximize the amount of drives on a particular node where scale-out makes the most sense, if you're able to maximize the amount of disk drive or the amount of SSDs on a node, you're going to be able to provide scale of capacity there. And then, as you actually scale the storage nodes, because, in some architectures where you have the compute and the disk drives very close to each other, you're actually going to see a far higher level of consistency in your operations. And let's all admit, when it comes to, the hosting business, it's not just about the hardware and the software. It's actually a lot about the operations that are behind it. And so as a result of scaling these storage nodes, you're able to scale your operations consistently as well. And one other thing to think about when you're thinking about scale up versus scale out is around the notion of raw versus usable capacity. And really what that's about is when you take say you have a compute node that's got 10 drives in it as a capacity point, and each one of those are 2 terabyte drives or 4 terabyte drives. It is going to be 4 terabytes is going to be your total capacity from those drives. But note that some of the software that's required and some of the infrastructure will be accessing some of that capacity as well. So it's not unusual to say that you've got 40 terabytes, or I should say 400 terabytes of 40 terabytes of information available. Of capacity available, but to actually see some portion of that taken for some of the logistics around the actual technology to use it itself. So there's this notion of what's raw versus what is actually usable, storable capacity. And then also the system nodes can actually further limit the object storage capacity as well, and that's kind of more around you're going to have some level of file structure in some of these environments, and that's going to take some of that storage consideration as well. So let's move on to the third topic here around the technologies that are existing out there. We've talked about the types of data that's out there. We've talked about the scale that you need to be considering, scale up and richness in some of the features, or scale out, which drives a little bit more cost benefit, although a little bit more complexity. Now let's talk about the types of technologies that are out there, and we'll talk about open source technologies as well as commercial technologies. And this is where for open source, you could be talking about OpenStack, Swift for object storage. You can be talking about the open source Ceph project, CEPH, object storage. You could also be talking about Hadoop as a big data analytics project, other NoSQL projects like Cassandra and MongoDB. There's a number of open source technologies that exist. We'll take a few minutes to talk about those as well as commercial offerings here. When we talk about open source, obviously some of the easy, quick benefits is that the actual license, there is no license associated with an open source package. And in the consideration side, we'll talk a little bit about what that means. I want to be careful that and there's a reason I said lower cost versus no cost. In some cases, there could be no cost, but in other cases, there are some support costs that exist, and there are other costs that exist, and we'll talk about that. Open source allows you, as a web hoster, to actually take a look at what's happening in the community, in the code itself. You don't have to be reliant on a software vendor. Not that that's a bad thing, but if you are so inclined, you actually have access to the actual code base itself. You could be a part of the global community and participate by contributing edits, by making code changes that you needed. And depending on the licensing that exists for the open source project, there's the license, there's the GPL type license. Depending on the licenses, there are various levels of contribution back to the community. So you can actually be a participant in this. And there actually are some studies around the innovation cycles that come with open source. So it's not just that you can see under it or you have access to it. It's possible that in some scenarios that innovation could actually be done more rapidly because there's such a large worldwide community working on things that you can actually see some innovation in some areas faster than other places that you would see with some commercial vendors. And of course, because this is community driven, the amount of resources that are available are significant, including, and I would say primarily, wikis and discussion forums. You can actually go to a lot of user forums, any of these open source projects, and see a variety of developers, a variety of users. And I should point out, it's not just developers. There are users that are out there that are communicating. How do you solve a problem? I have this particular use case. Does anybody have best practices? So you'll see a lot of that out there in that community, in those communities, talking about how practical implementation of this is done. Now, that you need to care about open source as well, and this kind of leads to my first point before. Open does not equal free, and the reason I say that is when you implement an open source project, it is typically simple, and that's really why a lot of the software vendors that exist out there exist, is because it is not a simple proposition to implement something so complicated. So usually costs manifest itself in terms of a support contract with a vendor that supports the open source project. It could manifest itself in additional staff that you may have not accounted for. It could account for for additional certifications for your staff that you may not have accounted for. And maintaining and keeping up with releases is also a full-time job in a lot of ways. So there are benefits in terms of no license cost, but there are other costs that are associated with it. Oftentimes, it's unless you go with a support package from a vendor, and when I say vendor in this particular case, for example, let's talk about Hadoop and how Hortonworks might be a good company that would support Hadoop, and there are obviously Cloudera and others that are out there doing it as well. But if you're going to support it yourself, you're going to have to support it. You're going to have to debug it. You'll have the community assets available, but it's going to take you and your team doing a little bit more yourself, and it gets a little hairier to support. It's definitely doable. A lot of customers do it. It's a little bit more arduous in some ways. The community focus, I mentioned that you can see innovation happening faster in the community, but what's happening in the community where the bulk of the interest may be, their interest may not be with your interest, right? If you're looking to see enhancements in terms of security in the open source project, it's possible that the open source community is far more focused on a user interface, and that's really where the next releases are coming. So there are ways that you can see faster innovation. It just may not be in the places that you want or need for your business. And you have to also understand that you have to be a participant in the community if you want to share the software project is actually going. There's a lot of folks that use open source software that are fine with using whatever the community is delivering. If you want to help get a little bit more, a little more specific focus on your areas, you have to be an active and vocal participant in the community, which can take some time and cycles as well. So let's talk about some of the commercial options that are out there. And this is a variety. There's a variety of companies that are out there that do this. A number that you already know. VMware and Microsoft have packages that do things like big data and object storage. There are other smaller companies that do the same, that are partners of ours, and that actually do quite a bit, that do similar things to what we described with the open source, but have either commercial enterprise products or support packages or consulting services to help you get these things implemented. So let's talk about some of these commercial. First of all, these are very similar to a lot of the packaged enterprise-grade software packages that you typically are probably used to, in terms of robust testing, robust use case development. Support packages and training are very streamlined, just because it's just the nature of enterprise software. They don't necessarily require you to have your own developers or to be a part of a community. This is what the commercial players are here to do. They want to make life easier for you, so they will do some of that work for you. And often these companies that are commercial entities, and I should note that some of these are companies that base their products on open source. It's not unusual to see enterprise versions of open source software. It's not unusual to see companies take open source versions and put a support package or a services package around it as an offering. So oftentimes they're partnered with companies like HP and actually delivering value. So that's those are all really important values that the commercial software brings. Important to consider some of the other items though when you talk about commercial. If you've worked with traditional enterprise software companies, you will find that the way conversations, you have a need or an area of focus you'd like the vendor to focus on, it's a roadmap discussion, and it is something where you provide your feedback to the vendor, they prioritize it and determine how they roll those sort of things out. It's not something where you as a user or you as an administrator can go in and modify the code. You can develop around it, but really you're kind of waiting for the vendor to come up with a new version, and you don't necessarily influence that roadmap as much as we would hope, because obviously these companies are looking and talking to a variety of various customers. Expertise is a little bit harder to come by as well in these areas as well. With the open source movement, you'll usually find a community that's worldwide of experts in a variety of different areas. There are experts that do exist for the commercial side of things. it's just not as widespread, and usually they will offer their services for a fee. Again, that's not necessarily a bad thing. If your focus is to make sure that you're delivering value to your customer, that uptime is is of the utmost. What you don't want to do is skimp on those sort of things. So finding expertise and even finding these resources, they're not necessarily as easy as you would see in the open source community, since those are so very open. But when you do find these experts, they do come with a fee, but they also have support and SLAs behind them to value it. So hopefully in talking about open source and commercial, hopefully I'm not swaying one or the other. I actually believe in both models personally. It really just depends on what you as a user need to implement for your service, and those are things that you need to consider when you're looking at what technology you want to for your service. So speaking of service, as I mentioned earlier, we're not in this alone. Companies like HP and other software players are all interested in making sure that you are successful in your journey here. So one of the things that you need to consider in these big data service setups is how much help do you feel like you are going to need? How involved do you want a provider to be involved with you? How accessible do you want them to be? And this can start all the way from basic consulting services. We can actually help you, or these companies can actually help you figure out how much service you actually need, and take a look at your environment and help you provide some guidance on how to build these big data practices. All the way through training on the specific technologies, and then once and as ongoing support. And there's a variety of ways that you can actually see these services rolled out. And to think about, and you need a budget for, a level of service that's available. I mentioned a number of the bigger players when it comes to commercial software, especially some of the bigger players in the storage spaces. You'll find that they actually have very robust services, very robust training. In some cases, you'll find certifications that exist. So as you look to hire or as you look to train your administrative staff, a lot of the commercial players have very strong certifications that exist, and you're actually starting to see that emerge a lot among the open source communities as well. For example, in the world of OpenStack, including what HP is doing in the OpenStack space with Helion, we're providing certifications, providing tools to be able to certification and administration easier, especially for as your staff changes, as you add more folks, as you bring in new graduates. There are trainings and services that are available with similar to a lot of the enterprise packages that you might encounter in any other part of your business. So thinking about service is actually going to be a very important component as well. And finally, in terms of the considerations that we need to have, let's talk about some more infrastructure requirements as well. These clusters, these nodes can actually contain hundreds and hundreds of, and maybe even thousands of worker nodes, also known as data nodes. That could be a compute node, it could be storage nodes, it could be both. It could be a combination of those. So when you look at how you want to tackle your big data service, you'll need to think about each of these individual nodes. Where do you want nodes that are going to be a little bit more storage oriented? In terms of secondary storage, where the analytics will actually be run fairly lightly. These are going to be nodes that are going to be, storage heavy, if I can say it that way, where I have a lot of disk drives populated, and this is specifically around the scale out kind of model. A lot of disks, as much as you can, attached to, compute. And so on the storage side of things, maybe you have a minimal amount of nodes and a maximum amount of drives. The converse of that is you're actually going to see some clusters that are actually, in order to run computations things that are extremely CPU intensive, you're going to want to make them a little bit more compute optimized, where you're going to actually have some level of local storage. But really what you're looking for is the horsepower. In a lot of cases, head nodes in these environments, as opposed to the data nodes, can be or will be important. That's really where these compute organized clusters will actually run. And then you've got these cases where either you don't know whether you need to be storage heavy or compute heavy, or you're just early in the process of determining how these things need to be rolled out. And that's where you need more of a balanced cluster, where you've got a amount of storage, a respectable amount of storage located and attached to the disk. Attached to the node, as well as some compute power on the front end of it. And you'll actually see, more of the Hadoop-oriented workloads look at having that type of an environment that's a little bit more balanced. And then actually, a few other considerations that we need to keep in mind. Think about sizing in particular. So as you're thinking about the type of clusters and whether it's storage or compute node or balanced, you need to think about how much data do you expect to have on a node. And what's important to consider here is not the maximum amount exclusively, but the fault zones, right? You need to think about, if there is an event, if there's a loss, or if there is a down event, how is it going to be recovered? What is the amount of data that's impacted? So a lot of our customers will actually go with a set fault zone so that they can manage that. And this is more of a best practice than it is an infrastructure physical item, but it's something that you have to consider, right? What's the recovery method for data, and what's the maximum that you want to have on a particular data node? Because applications are requiring this, these data areas available to them, you have to consider compute for these applications as well. And this is really where this compute plus storage balanced or the compute and storage clusters. This is where the scale out. It says scale horizontally here, but the scale out, which is the same thing, model makes a whole lot of sense. Is because these applications can actually very quickly manage to find the data they need to get to, and because compute and storage are so close, there is the amount of time the I/O is significantly improved. So one of the things that you have to consider is how much compute power is your application going to actually require as a means to actually access this data, to store it, to analyze it, and things like that. And you also need to think about the applications themselves. More and more of these applications are being written with with cloud in mind. So how we actually see the cloud running is with a high level of redundancy, looking at storage as pools of storage, the ability to actually have multi-tenancy in these environments. So you have to have a clear understanding of when your applications will run, when it will store data, and when all those data and applications are going to be accessed. When will it be accessed at the same time, and will your environment with your compute nodes and storage nodes be able to handle the load that will be placed on it as a result of that? So this is obviously quite a few considerations that you would think about, especially just on the infrastructure side of it. And this is really where, as I talk to customers about this, really where I say, look, there's quite a bit that you can do and build yourself. But this is where I think it makes it much, much simpler to go and find a partner to partner with and work on a solution that has worked for others, that has worked in similar environments to yours. And this is where I think reference architectures and use cases and case studies of how people are doing this make a lot of sense. And that's where partners actually provide a lot of value to you. The scale up and scale out question that I mentioned, we happen to be in both businesses, right? That help you decide which one is the best for your business, and then provide you the solutions around either of those models. And in terms of the actual types of data, we manage to be able to leverage a lot of the newer technologies that are out there to be able to handle both of those. When it comes to open source, when it comes to commercial, we're able to provide you that same level of insight in terms of what makes most sense. And infrastructure is our business, as well as many other businesses that HP conducts. But infrastructure is our business. We get it. We understand where optimal configurations make the most sense. And big data and object storage is a big passion of ours. So it's something that we certainly can offer a level of help in as you're looking to implement something like this. Let me just take a moment and talk about the SL 4540. And the reason I'm bringing this particular platform up is that it has actually been designed specifically for big data and object storage use cases. Let me be very clear. And this is a storage cluster type a configuration that I mentioned before. It's actually been developed to hold a variety of configurations. You can actually have 1, 2, or 3 nodes in a chassis here. And you can actually, for example, in the 1-node configuration, you can actually have up to 60 large form factor drives attached to that one node. And as a result of doing that, and obviously with the 2 nodes, you can there's less disk because you have a little more real estate, but two nodes with 25 drives each, three nodes with 15 drives each. And depending on the use cases, it actually makes a whole lot of sense to look at a 4540 type of an infrastructure, just because it allows you to be able to access and analyze data very, very rapidly in that scale-out model. And a couple that are here that is very important to highlight, because of the configuration of the limited number of nodes and the maxed out number of disks, we can actually get up to 3.2 petabytes of capacity in an entire rack, which, if you think about object storage or for big data type use cases, it is actually a very powerful way to actually go and access your data and make these data points available to your customers. Scalable, because it builds out in that scale-out model. Because we are focused on density optimized, the denseness of the platform, the denseness of the chassis, as well as the ability to save as much power as we can, are built into the design of how we actually do the 4540. So, I don't want to spend too much time on it. I just want to make sure that this was available and as information to you as you're looking at building this out. And I would be remiss if I didn't go into the fact that HP has invested heavily in big data and object storage across our portfolio. As Cheryl mentioned, I'm particularly in the infrastructure server part of the business, where we're building out a lot of these big data and object storage type solutions. But HP has actually invested quite a bit, all the way from what we do in our storage business, where we've been leading storage for a very, very long time, with our store all capabilities, with what we're doing with 3PAR, as well as some of the software elements we have with autonomy, with products like Vertica, and then obviously our services group. We actually have a dedicated big data practice, and there's solutions across the board in terms of converged systems. In terms of ARM-based systems, there's quite a bit that HP has invested in terms of big data and object storage. And so I want to make sure that you know that these are all available to you. And obviously, if you talk to your HP person, HP rep, then they can get you connected with any of these, including a consulting service, probably to help you figure out how you get started. So in conclusion, let me just say that big data as a service is actually a very viable business offering that a lot of web hosters, maybe a number of you have already started getting into that space. A number may already be delivering very lucrative services and businesses around big data and object storage today. For those of you who are just now thinking about it or just getting started, or are looking for ways to improve your big data service, I'd welcome you to work with us at HP to help you figure out what solution of our broad portfolio makes the most sense for you. Help understand your need. At the end of the day, we're not looking to push a particular type of technology, a particular infrastructure. What we want to do is figure out what is the best possible solution for you and make sure that you can be successful with it. I mentioned a lot of the commercial partnerships that we have, and I mentioned the open source options that we have available as well. Whether it's in the cloud, whether it's on your premise, whether it's a mix of the two, HP is committed to all those delivery models. And here's the thing, big data and object storage, like most things in this emerging technology world, are things going to stand still. It's not going to stay static. It will change, it will evolve, it will get better. New advancements will come. Our commitment to you is that we will continue to investigate these technologies and figure out how we can enable these technologies for you, our customers, to take advantage of it and actually make your businesses more successful. So I do thank you for your time, and I will just leave this kind of last slide up, a URL to hp.com/go/big data, where you can learn more about what HP is doing in the big data and object storage space. And thanks for your time today. Cheryl, I'll hand it back over to you.
Yeah, thanks so much, Joseph. We have time for maybe just one or two questions from the audience. So I'll go ahead and give you the first one, is that you mentioned a while back in the presentation that there was open source versus commercial. Sorry, my screen just kind of blanked out there for a second. But you could talk maybe just a little bit more about what those hidden costs might be. There was a question around why would I choose, your source versus an open source solution.
Yeah, great question. And the way to think about it is, and the costs that are associated with a commercial product are fairly upfront, right? There's a license fee that's associated with it. There's usually a service agreement that comes with it, and then there is an ongoing support contract, things like that. So it's very tangible, especially for if you're looking at a assets and liability accounting form. You can actually see where the costs are coming from, what cost centers are coming out of it. So in some ways it looks like it is that it's just a heavy cost. But what you have to remember with these commercial solutions, that they are designed and built to make life simple and easy for their customers. They spend a lot of time in quality assurance. They spend a lot of time in meeting with customers to figure out what features are needed, and they stand behind it very, very often. They stand behind it, and if there are customer issues that pop up, they're 100% with these support contracts. And in open source, and let me be very clear, I'm separating out the open source project, meaning no vendors involved. Like for example, I mentioned Hadoop and Hortonworks. If you're just look at Hadoop as a technology and not work with someone like Hortonworks or another Hadoop vendor like Cloudera, if you're not going to partner with them and just on the open source side of things, you're basically on your own ways, right? You have a broad community of people that are available to you, but let's be frank, they have their own day jobs as well. They have their own priorities. They're going to be driving their own. So some of the hidden costs with your open source engagement would be you're going to need to enhance your staff. That might mean hiring a few people that are very well versed in the technology. It might be training your staff. It might be just getting them ramped up on the new technology. It might be going and testing these open source technologies out for the first time in your environment, which means you don't know what the end results will be. Those are all things that commercial products will end up having tested at some point as part of their delivery process. This is not to say that because those costs are not there, additional staff and additional time, just because those hidden costs are there, make it the wrong choice. I know a number of customers that have decided to go down that path, were willing to make the investment of hiring some additional staff and training their folks and becoming contributors to an open source project, and it's wildly successful when it comes to those open source projects. But a lot of times they were aware that that was going to require them to make some other investments other than license costs. So when we talk about some of those hidden costs, it's not as apparent as a license fee. It's not as apparent as a support contract. but it ends up being time, it ends up being additional headcount that you might need that have expertise. And those are a lot of times customers don't consider when they look at open source. A lot of times they look at it as a free way to do something, when in fact there are some costs that are there.
Great, thank you. And there was one other great question, and we just have about 1 more minute, so I don't know whether you can answer this quickly.
Okay, I'll try and be
but you mentioned, because I think this is a good one actually, the 4500 server, you mentioned that it was specifically built for big data, and the question was whether you could give maybe a couple examples of big data technology that's sit on that type of server at the moment. Yeah,
great question. I will be brief on that. So as I mentioned, there's 3 different configurations. There's what we call a 1x60, which is a 160 drive configuration, and that's really great for object storage and cold storage mainly. So if you have data that is going to be maybe not written to, or if you've got if you've got data that's going to need to be archived, and just basic object storage type solutions, that's a great configuration for it because of the disks that are associated with that one node. In a 2x25 configuration, which is 2 nodes in the chassis and 25 drives attached to each node, that's actually great for setup, things like Exchange. We see a lot of our customers actually use it, and that's how that's what we had in mind was those sort of mailbox oriented type environment. So the 2x25 configuration makes a whole lot of sense. And then the last configuration, the 3x15, which is 3 individual compute nodes with 15 drives associated with each, fantastic for a Hadoop type implementation, in that Hadoop requires everything to be saved in triplicate, and because of the 3 nodes and 15 drives with each, your processor to spindle count works perfectly for Hadoop. So that one model, multiple configurations that work great for a number of these use cases here.
Okay, perfect. Thank you so much, Joseph. That's all the time we have for today, unfortunately. So I'd like to thank everyone for attending and submitting your questions. Again, if we didn't get to it for some reason, we can be contacted after the webinar. And also I'd like to just thank you again, Joseph, for the presentation today. So everyone have a great day, and we hope to see you again on another WER webinar.